Welcome back, calculus students, and welcome to Module 3. In this section, in 3.1 of Module 3, we're going to be looking more into derivatives and learning about something called the product rule. Let's get started. So we're going to do some sort of exploration when we're talking about the product rule, and we're going to look at, okay, where is this coming from, and why is this, what is the product rule, and why is it the way it is. So what we're going to do is we're going to rewrite this as a cubic function and then find f prime of x. Okay. So well, we have f of x here, so let's write f of x equals, and then we're going to distribute everything. So I'll get let's see, 2x cubed minus 4x squared plus 2x minus 3x squared plus 6x minus 3. That looks good. And then what I'm going to do with that is I am going to just combine like terms real quick. So f of x is going to be, let's see, that is going to be 2x cubed minus 7x squared plus 8x minus 3. All right, and now let's find f prime. All right, so f prime of x, so taking that derivative using the power rule, so that's going to be 6x squared. I'll bring the 2 down, multiply by 7, so minus 14x, and subtract 1 from the exponent. So that's going to be a 1 right there. And then plus 8. And then minus 3, a constant, comes out to be 0. All right, so what we want to think about is, what does f prime represent? So f prime of x is an equation that can be used to find the slope at any x value of f of x. So we just found f prime here, and we know, like, okay, we can distribute here and we can find the derivative using the power rule that we learned about in our previous module. And again, reiterating that idea, f prime is the slope that we can use, or that we can find at any x value for f of x. So the history of calculus is a little bit convoluted, but generally speaking, Isaac Newton and Gottfried Leibniz, they pretty much came up with calculus in separate areas of Europe at the same time. Unfortunately, and this is a really, it's a much longer story, but Gottfried Leibniz died in shame because he actually made a mistake, a very small minor mistake, and Isaac Newton accused him of theft, of stealing his own ideas. But what I want to get at is, what is the product rule? What did they come up with in 1673? And so what we know is, if we have a function h of x, and that is the product of two smaller functions, f of x times g of x, okay, so two smaller equations right there. Well, then h prime of x is equal to f prime of x times g of x plus f of x times g prime of x. And so here's how I like to remember this. If I have two things getting multiplied and I am going to take that derivative, it's going to be the derivative of the first times the second plus the first times the derivative of the second. So the first and second equation, or the first and second function here. So we're going to show that this works real quick by taking the derivative using the product rule that I just wrote above. And in order to do that, let's start writing this f prime of x here. And so that's going to be the derivative of the first. So I'm going to have that in blue, and I'll have the second in red. So the derivative of the first is going to be 2, and then times the second. So I'm going to hold on to the second. So x squared minus 2x plus 1 plus the first, so hold on to the first, so 2x minus 3, times the derivative of the second. So that's going to be 2x minus 2. And now we just need to simplify this real quick. So that's going to be 2x squared minus 4x plus 2 plus, all right, we got a first outside inside last this one, FOIL it. And we're going to get 4x squared minus 4x minus 6x plus 6. All right, that looks good. All right, so that gets me 6x squared minus 8x. Oh wait, I made a small error. Minus 8x. I forgot to do the 6. So minus 8 minus 6. So that's minus 14x. And then 2 plus 6 is plus 8. And at this point, we're going to go up and we're going to compare that to what we just had. 6x squared minus 14 plus x plus 8. Is that what we had a second ago? 6x squared minus 14x plus 8. So that proves that using this sort of product rule, we're able to get to the same solution. So you might be thinking right before we get into this, is that why would I use the power rule, or sorry, why would I use the product rule when like I could just distribute everything and get the same exact answer? And in cases where you have polynomials that you can distribute, I highly encourage you just distribute and use the power rule. It'll work great every single time. But we don't always have that luxury. In an example of this, when we have some trig functions or some weird functions, and it's going to be a little bit too complicated to distribute. Like you can't even distribute something like this. So then that's where we really want to use the product rule. Okay, so I've got two functions. I've got x squared and I've got sine of x. And what I want to do with this is I want to find the normal line, find the slope of the normal line. I don't want to find the full equation of the normal line, just the slope. All right, so let's take that derivative. So I have g prime of x, and that's going to be the derivative of the first, so 2x times the second, plus the first, so x squared, times the derivative of the second. So sine, the derivative of sine is cosine of x. Okay, and now I want to find the slope of the tangent line. So let's find the slope of the tangent. And what are we going to find? So we need g prime, and we want to find it when x equals pi. So g prime of pi. And so that's going to be 2 pi times the sine of pi plus pi squared times cosine of pi. All right, so then 2 pi times sine of pi, that's going to get 0, plus pi squared times -1. So this comes out to be negative pi squared. A pretty nice looking expression right there. So if I want the slope of the normal line, that's going to be the negative reciprocal. So the slope of the normal line is going to be the negative reciprocal, so 1 over pi squared. And that's going to be our final answer for that slope of the normal line. That's all we need to find. We didn't need to find the full equation for that normal line here, but we could if we wanted to. So this product rule, this is going to be something that you're going to really want to get down. That product rule for differentiation, you're going to really want to get that. And you might be wondering, is there one for quotients when we have some division? And yes, we will be getting into that, but stay tuned in this next lesson where we're going to be practicing the product rule when we're giving several functions. I really want you guys to get that practice down and go into that homework where you're able to practice this idea in many different scenarios. So please stay with it. If you do need any help, make sure you guys do reach out to me. I'm Mr. Hernandez, and this was Mr. Hernandez Teaches.